Hi friends, today we will discuss about ruby laser and helium neon laser. This is very important topic for students of high school level and undergraduate and postgraduate levels, and those who are dealing with the research in lasers. This folder in our YouTube channel on lasers are going to be very much helpful to you. So here in this slide, you can see three pictures about ruby laser. The first picture shows you some of the ruby laser crystals that are grown by several researchers worldwide. Okay, so you can see on the first picture that ruby laser crystals, that is the laser rods of cylindrical dimensions of varying diameters, are grown and they are placed and shown to you. So this helps you to understand how the ruby laser crystals are available, how they appear. They are appearing almost like a pink color solid stuff. Okay, they are grown by the process of single crystal growth by adopting Jagrodsky crystal pulling technique or by Bridgman technique, so that we end up with cylindrical, highly polished single crystals of ruby. So in the second picture, you can see that the ruby laser rod, which is cylindrical in shape, is placed in some particular container for realizing the laser action. So what is that container? How it is made of? We will be seeing that. So the first picture shows you the as grown ruby laser rods. Second crystal shows you how the rods are placed inside the container or the setup. And the third picture tells you upon operation what color light comes out. What is the nature of radiation that is emanating from the ruby laser rod? You can see through the picture that it is a reddish color radiation, and the person who is operating it is doing some action like laser welding or cutting of metals. So you can see that the laser beam is focused onto some metallic plates wherein the process is carried out. Remember friends, whenever we are using lasers, we should be very much careful that the laser radiation should not hit our eye directly, because even low power lasers can damage our eyes to a great extent. So like the person who is wearing some goggles in order to prevent the laser radiation from damaging his eyes, we should be very much careful in handling lasers. So this three picture gives you some pictorial representation of lasers, of the ruby laser. In general, a ruby laser is nothing but a solid state laser. As I told you earlier, based on the nature of active medium that is present in the material for laser action, we will classify the laser as solid state laser, liquid laser, or gas laser, or semiconductor laser. Here, as we understand, ruby rod is made of alumina single crystals which are doped with chromium ions. So chromium ion acts as the activator ions. This chromium, which is in the Cr3 plus state, it is doped in the alumina crystal. So Al2O3 alumina is the host matrix. Alumina as such, it cannot generate laser. Okay, so it is purely inert, it will not generate any light radiation. So it is acting as the host material, and in that we are doping 0.05 percentage of chromium ions only. You please see how this smallest concentration of chromium is going to help us to realize laser action. So in general, these chromium ions can absorb blue color and green radiations. So they are carefully or very well, since their energy levels are favorable to absorb blue and green radiations, the chromium ions can efficiently capture them. And now you can see the figure of the setup, how the ruby rod of length 4 centimeter and diameter of the order of 1 centimeter is used here. It is placed in at the center, and around the ruby rod you can see that some flash lamp is wound on it. This flash lamp is nothing but xenon flash lamp. So it is wound helically on the ruby rod. Helically means it is a spiral arrangement. It is very clearly wound. So here in the lower portion you can see the diagram of how it is, and in the first figure on the top you can see how the photograph looks like. So the flash lamp is sealed well and it is connected to the power supply, and the two rear ends of the ruby rod are very well polished. One side we will polish it 100%, another side we will polish it nearly around 99.99 percentage, so that the laser beam can come out of that particular surface. So this has to be properly sealed. And what happens here is, this ruby rod, we have understood it is made of chromium ions doped on alumina. So chromium ions are going to act as the active centers, and it is a solid state laser. Now, in order to pump the chromium ions, what we have to do is we have to switch on the xenon flash lamp. So this switching on is done with the help of this power supply placed here. So when the xenon flash lamp is switched on, it will generate white color light. So white color means it's a combination of VIBGYOR colors. So predominantly combination of red, blue and green wavelengths. So when this happens, only the blue and the green wavelengths are absorbed by the chromium ions, because their characteristic absorption wavelengths fall in this particular regions. All other wavelengths, they are not absorbed. So how the lasing occurs is shown here. This chromium ions has two absorption bands and a metastable state. The picture that is shown to you here on your right hand side is the energy level diagram of only the chromium ions that are present in the lattice. So we are not worried about the energy level diagram of alumina, though it is occupying 99.95% of the crystal. Why? It is because the alumina, the energy levels of alumina, they are not going to help us in laser action. So just we will concentrate about the energy level diagram of chromium ions. So this is the energy level diagram of chromium in the 3 plus state, which is called as the 3 plus Cr3 plus state. I am showing you here. So how it appears? You can see the chromium ions has two absorption bands, one for green radiation, the other for the blue color radiation, and it has one metastable state here. So when the flash lamp is switched on, the radiation, that is the white radiation, which is consisting of the blue photons and the green photons, they are effectively absorbed by chromium ions, and the atoms from the ground state atoms of chromium move to the excited states of, which are shown here through the blue color shaded region and the red color shaded region, which are normally E3 levels and E3 dash levels of the chromium ions. From those higher energy levels, because the lifetime of these energy levels are very minimum, they will now, these excited state atoms will undergo non-radiative transition to the metastable state. So the metastable state is shown to you here. So the atoms are now making a quick jump to the metastable state, and the lifetime of this metastable state is found to be 1000 times higher compared to the lifetime of the E3 and E3 dash levels, which are nothing but these two levels which are characteristic of the pump levels due to green and the blue radiations. Once now this happens, there is a state of population inversion that is established between this metastable state and the ground level. So where does the population inversion occur? Here between these two levels, and not with respect to the E3, E3 dash level. Okay. Now what happens here is first one photon is generated out because of the transition from the excited state, or we can say from the metastable state to the ground level. So that photon, outcoming photon, will again go and knock one more atom which is present in the metastable state, and that atom comes to the ground state with the emission of two photons. So those two photons again move to reach or collide with two more atoms in the metastable state. Thereby, this transition leads to the laser output with the wavelength of 694.3 nanometer, which is nothing but the red color radiation. As we have discussed in the previous video, the transition between the levels E3 and E2 or E3 dash and E2, they are due to non-radiative transitions only. So laser radiation will not be emitted due to these transitions. Only heat will be generated. So here it is a non-radiative process, and here the transition between metastable state to the ground level is a radiative transition process. So that is explained in this figure, in this slide as well. So what happens, very importantly, what we have to note down is that the red photons with the wavelength 694.3 nanometer or 6943 angstrom will be generated, and this will be constantly reflected between the end mirrors, and hence the amplification of the light will occur. And in general, once a stimulated transition starts, the metastable state will get depopulated. That means once this transition starts from the metastable state to the ground level, when the atoms are when they are moving to the ground level with the generation of laser, then a stage is reached once when the metastable state will become empty, or we can say the number of the percentage of atoms in the metastable state compared to that of the ground level will not be a condition that satisfies the population inversion. So laser will stop generation. The generation of laser will stop for some time. So again, what should be done? The flash lamps which should be switched on, so that the atoms which are in the ground level will move to the E3 and E3 dash levels by the absorption of blue and green radiations, and then they will come down to the metastable state through non-radiative transition process. Later they will come to the ground level through the process of stimulated action. So when you take as the when we draw a graph with respect to time along the x-axis and pulse output along the y-axis, we can see that there we won't have laser pulse for some time, and later for few microseconds laser pulse will be available, and later it will go to 0, and then it will increase, then it will reduce. So it is like a pulsed output. We are not having continuous laser output by operating ruby laser, because the metastable state will undergo continuous population inversion, will continuously satisfy the population inversion process, and sometimes it will not. So it has to regain. Once this condition is satisfied, so long as the condition is satisfied, we will have pulse output. Once the condition is not satisfied, the output will go to 0 level. So the main prominent features of the ruby lasers are, as you see through the figure, it involves 3 level sources. Only this is the ground level. This the metastable state is taken as the second level. Here this level E3 dash is considered to be the same level only. So it is a 3 level system. And the main active centers which are responsible for laser action are chromium ions. They are the activator ions here, and the pumping mechanism adopted here is through optical pumping with the help of xenon flash lamps. And these lasers, that is the ruby laser, can generate only pulsed output. We cannot have a continuous laser beam generated out of the ruby laser. So we have seen what is a ruby laser, how it is made, how it is fabricated, and how it is operated. and I have explained to you the energy level diagram of ruby laser. Now with this understanding, we will go to the next laser, which is nothing but helium neon laser. My dear friends, please see here in the periodic table of elements, as I told you in the introductory lectures, all atoms with of different species cannot be used for laser action because suitable or favorable energy levels should exist in those atoms for realizing laser action. This gas lasers is made of the inert gases, which are nothing but helium and neon. We have to choose them in proper concentrations or in proper compositions so that the tube that is filled with these gases can be made to generate lasers. So here we are going to employ the inert gases. So that is the understanding from seeing the periodic table of elements. When we say inert gases, they are not going to react with each other, rather they are distinctly available within the container. And on the second picture you can see where upon operation the tube that is filled with helium neon laser also generates the red color wavelength like that of the ruby laser, but still their wavelengths are different. Though they appear to be red, their wavelengths are different in nature. So we will move to the explanation. Here is the explanation. When you consider the helium neon laser, it is a gas laser because the active medium here is nothing but the mixture of gases helium and neon. In normally these gas lasers, when you take high power gas lasers like carbon dioxide lasers, they are used in industries. Low power lasers like helium neon lasers, they are available in very normal physics laboratories also. So gas lasers can operate with high powers and low powers also. In general, gas lasers will use rarefied gases as the active media and are normally excited. That means they are excited means they will be pumped by the help of the electric discharges. Electric discharge means in the setup we should have an anode and the cathode so that we maintain them with a high at a high potential difference and the electric discharge will be created. So here in general gases will have very narrow energy levels. So when the energy levels in the gases are very narrow, we are unable to use optical pumping because in optical pumping there is a chance of broad emission of wavelength. For example, in the previous case we saw that ruby laser was pumped with the help of xenon flash lamp, which is generating wide range of wavelengths. For I told you xenon laser will generate xenon flash lamp will generate white color radiation. So it is nothing but combination of VIBGYOR colors. So more is the spectrum of emission. But here in general these gases will get excited only with the sharp wavelengths because their energy levels are very narrow. So in order to achieve this task, we will be using the excitation with the electric discharges. Okay, so that's why normally in gas lasers excitation or pumping is not done by optical pumping methods. You should know as students, it is very essential for you to know this concept. Okay, in helium neon laser was the first gas laser which was developed by scientists Ali Jawan, William Bennett and Donald Heriot in the year 1961. You can see on the right hand side the picture of a typical helium neon laser. Here the discharge tube, that is the tube which is containing the gas mixture, is very clearly sealed with the helium neon gas mixture. Helium will be in the concentration of 10 and neon atoms will be 1. So helium is to neon gas mixture will be at a composition 10 is to 1 and neon atoms are the active centers. So though they occupy lesser composition or lesser volume, they are going to act as the responsible atoms for laser generation. So what will helium do? Helium will help to excite the neon atoms only. They are going to help us to give some energy to neon atoms, and neon atoms are only responsible for laser action. And this tube has, it is very clearly sealed, hermetically sealed means it's fully airtightly it will be sealed, so that even a drop of air should not get inside. So properly they will be sealed, and at the two ends you can see the Brewster's windows, they are placed at proper angles in between the mirrors. For one is 100% reflecting mirror, the other is partially reflecting mirror. So they are, this discharge tube is at the two ends we have cathode and the anode, and the distance between the mirrors will be adjusted to be m into lambda by 2, such that the resonator supports the standing wave pattern. Because normally, my dear friends, please understand, there is a concept called longitudinal modes and the transverse modes when it comes to the beam profile of lasers, which are very much dependent on the dimensions of the laser tube or the resonator cavity. So we have to peculiarly design this tube in that particular angle, taking into all those conditions into account. So one thing you should understand here is that length of the tube will be very much higher compared to the diameter of the tube. That's why the tube is called as a narrow discharge tube. And why the tube has to be narrow, why the diameter of the tube cannot be higher, we will see the reason in the next slide. So here comes the explanation about the pumping mechanism. I have given you a detailed explanation here for you to read through whenever you are free. You can stop the video and read, but now I will explain you only the energy level diagram. So when we are supplying a voltage of the order of 10 kilovolt between the cathode and the anode, that will ionize the gas, which is nothing but helium neon mixture. It will be ionized. Normally, because of the collision with respect to the electrons and the ions that are generated, helium atom will get excited first. So you may ask a question, why helium atom is getting excited first, why not neon atom is getting excited first? We may have that question. The main reason is that helium atoms are lighter in nature, so it is very easy for them to pick up the energy that is given by these electrons and ions due to collision. That's why helium atoms will get excited first and they move to the excited energy levels. Later, what happens here is that, see, my dear friends, these are the metastable levels of helium atoms. So, they cannot, the helium atoms in the excited state, they cannot come to the ground state by the release of laser radiation. Okay, by spontaneous emission also, it cannot emit light. Why? These levels are not the stable levels, they are metastable levels only. So they cannot generate light radiation. Rather, the helium atom can come to the ground state by giving this energy to the neon atoms. So neon atoms are, first they are not excited because of the ions and the electrons generated due to the electric discharge, because they are heavier. So what these helium atoms do, they have already got excited, but they cannot give out light radiation. But they have to give this energy to neon atoms so that they can come down to the lower levels. So what happens here is, the energy acquired by these helium atoms is efficiently transferred to the neon atoms. So the neon atoms from the ground level, they quickly, by the process of resonant energy transfer, they absorb the energy of the helium atoms and move to the excited level. Okay, and from their excited levels, these atoms can come to the level 3p and then to 3s, and then they can come down to the ground levels. So the transition from 5s or 4s level of neon atom to the energy level 3p will be radiative in nature. They can emit light radiation or laser radiation with wavelength 632.8 nanometer or 1.15 micrometer, and later from 3p they can come through the non-radiative process to the energy level 3s. Okay, So this will be a non-radiative transition only. And in general, it is difficult for the atoms in the energy level 3s to come down to the neon, the ground level of neon, so that in order to make these atoms to come down to the ground state, they can, by losing energy. That is why the discharge tube is made to be very narrow, because these neon atoms will go and collide with the discharge tube, with the walls of the discharge tube, and they will lose energy, and then only they will come to the ground state. So it is very difficult otherwise for neon atoms to lose energy, because where they will give the energy, so they have to lose, only then they will come to the ground state. That's why the discharge tube is made narrow. That's why I told you this question will be answered in the next slide. Here I have written why the discharge tube should be made narrow. The reason is the only way of bringing neon atoms to ground level is by the process of collision. So to make more collisions with the walls, it is very easier if the diameter of the tube is lesser. Only then more collisions can happen. Otherwise, when the diameter is more, it is the probability of atomic collision with the tube walls will be very lesser. That's why it is made narrow in nature. So though two laser radiations are possible, 1.15 micrometer and 632.8 nanometer are possible, normally one radiation alone, around 632.8 nanometer alone, is made to come out of the tube by carefully designing the parameters of the tube. So you have understood here the energy level diagram of helium and neon. The energy levels, that is the excited state level of neon and this metastable state of the helium, are very much closer. That's why these two gases are chosen and the combination is chosen. Since helium ion is lighter in nature, it is picking up the energy due to electron collision and moves to the excited state, and helium atoms do not have the ability to luminous. They cannot give out spontaneous emission or stimulated emission, because they are, these two levels are metastable levels. Okay, so they cannot come down with the emission process. So they in general transfer the energy to the neon atoms, wherein this process is termed as the resonant energy transfer. And this the laser action that is taking place in neon atoms are explained to you here. And the main features of the helium neon lasers are it adopts a 4-level pumping scheme. Like in ruby laser there have been 3-level pumping scheme, here we have 4-level scheme. And the main centers or atomic species that are responsible for laser action are neon atoms, and we are achieving the pumping process with the help of electrical discharge by applying a high potential difference of the order of 10 kilovolt or more. We can achieve the population inversion and the pumping can be done. So here this occupies in the continuous wave mode. So we will have laser pulses throughout the experiment. It will not stop for few microseconds and it will not be radiated, because the population inversion occurs between these two states. It's always available. So it takes time for the atoms are available in the excited levels continuously. So the population inversion state is available throughout, and hence we have continuous wave lasers. And here I am summarizing the two lasers, ruby lasers, along with the here Here I am summarizing to you both the types of lasers, ruby laser and helium neon laser. So ruby laser is a solid state laser and helium neon is a gas laser. And when you take the mode of pumping adopted in ruby laser, it's optical pumping with the help of xenon flash lamp. And in helium neon laser, it is through electric discharge. We are applying a potential difference of the order of few kilovolts between the anode and the cathode, and we are ionizing the gas. And the pumping scheme here in ruby laser is 3-level pumping, and helium neon laser it is 4-level pumping. The activator ions that are available in ruby lasers are chromium ions. Here the neon atoms are the activator species. The host matrix for ruby laser is alumina Al2O3. In helium neon laser, it is helium atoms, they are occupying much volume. The efficiency of both the lasers are lesser only. And mode of operation, when you consider, ruby laser can function as pulsed mode laser output, and helium neon can work in continuous wave laser output. And both are emitting the laser radiation in red color, but still there is a difference in the output wavelength. Ruby laser emits 694.3 nanometer radiation and helium neon laser emits 632.8 nanometer radiation. My sincere thanks to you all. Please refer these books and the web references. If you have any questions, kindly post in the comment box. Thank you. Next, we will have a discussion on semiconductor diode laser. Thank you very much. Good day to you.